So far, I've only looked at single item auction. So the first and second price were for single item, and the example on eBay was also for single item. Of course, in ad space auction, you have multiple ad spaces on the same page. For example, 3 ad spaces, 1, 2, and 3. And let's say they're ordered in descending order of their visual importance on the web page. And let's say the click-through rate are respectively 5, and then smaller 3, and then smallest 1 click per unit of time, say 1 hour. So now our job is to allocate not just 1 but 3 items and then charge them accordingly. As we just mentioned, that Google runs the so-called generalized second price auction. So what is that? Let's illustrate that with this particular example. On the right hand side are the products, in this case ad spaces, the items. On the left hand side we draw a list of 3 bidders, okay, labeled 1, 2, and 3. It doesn't have to be 3, it could be 4, it could be 2, but in this case we just let n be the same as k, and both are 3 for simplicity of illustration. And each of these bidders is an advertiser, and they have an expected revenue per click, which is $10 per click, $5 per click, and $1 per click. And obviously we have ordered these 3 bidders in descending order of their revenues per click. So these are the R values, and these are the C values, the click-through rates for each ad space and the expected revenue per click for each of the 3 buyers. And what GSP does is to say each bidder can send in a vector of bids, okay, because there are 3 items. But that vector actually is just a scalar. It is really what they value for each click, their valuation per click. Now they can choose to submit a bid that's the actual revenue per click, the true valuation per click, if they want to follow a truthful bidding pattern, or they can pick any other number. It could be a fictitious valuation per click. That's the single number submitted to Google by each bidder. But we can also view that as a vector. It is just that scalar, this valuation per click, multiplying the vector of click-through rates. In this case is 531. So for example, if the 3 bidders all decide to do truthful bidding, meaning that they will each submit 10, 5, and 1 respectively as their bids, the true valuation per click, then that's equivalent to saying that bidder 1 is submitting a vector consisting of 3 bids. 10 times 5, 50. 10 times 3, 30. And 10 times 1, 10. Because this is just a scaled version of the click-through rate vector. The scaling, the proportionality constant, is the scalar bid. So we can view it either as a scalar bid or as a vector bid. Either way, because this vector is truly just the scalar multiplying the given constant click-through rate. Similarly, buyer 2 submit a truthful valuation, suppose, okay, and that will be 5. That's the bid. We can also view that as a vector of 5 times 5, 25 for the first ad space, 5 times 3, 15 for the second ad space, and 5 times 1, which is 5 for the third ad space. Similarly for the third bidder as well, either a scalar bid 1 or a vector bid of 5, 3, 1 for the 3 ad spaces respectively. Now we have something called a bipartite graph. We'll come back to this in a minute. We have on the left hand side these 3 bidders, on the right hand side these ad spaces, and our job is to match these white dots with the black dots. By matching, we mean that each one of these white dots would be matched to one and exactly one of these black dots. Since n equals k, we'll see basically a perfect match. One white dot matching to one black dot, and all white and all black dots will be matched. So there are actually quite a few possibilities here, because this one can be matched to any one of the three black ones. Now we have to decide which one to match. That is the allocation part of GSP. And the GSP rule says that it's quite simple. We just match the top ad space, the most valuable ad space, to the highest bidder, and match the second valuable space to the second highest bidder, the third valuable space to the third highest bidder. In this case, since both left and right sides have been already arranged in descending order, the matching is a simple horizontal matching. That is the matching that GSP would provide. And then GSP need to decide the charges, how to charge. And it generalized the second price simply by saying, well, the top ad space given to the top bidder will be charged by the bid from the second highest bidder. Okay, so in this case would be 25. And the second highest most valuable ad space given to the second highest bidder, the charge will be according to the third highest bidder. Now, since there are only 3 items and 3 bidders, what about the third pair? Well, you can either say they get charged nothing, or in reality they always have a minimum, let's say a delta of charge. So it would be charged delta dollars per click. The delta, let's say, equals $0.5. Okay, that's the very bare minimum that Google has to charge you, because there's no lower bidder than you now. So this is the process of GSP. So again, let's take a look at this example. Okay. The bidding is basically for each buyer, there's a bid scalar BI, which multiplies the vector of C1, C2, CK for K items. These are the click-through rates for each item. They are multiplied by BI. So you can either view this as a scalar bid, or you can view it as a vector bid of BI, C1, BI, C2, BI, CK. The allocation is very simple. The ith highest bidder gets the ith most valuable ad space. And the charging mechanism is that the ith one charged by the one below it, the I plus 1th bid. Unless you have no one below you, then you just charged by the basic minimum dollars per click. Okay. So before we go on further, a very quick detour on 2 questions. 1, we brought this up briefly before. Why not let each buyer submit an actual vector of multiple bids? For example, instead of saying it's a scalar, say 10 times the vector of click-through rates 531, how about we ask them to submit a truly different entries in the vector, not just all multiples of this given click-through vector, for example 100, 5, and 1. Okay, just to say that I really value the top slot so much, and I'm willing to bid a lot more for the very top one. And indeed, that would be the more general scenario. The only reason we're not using that scenario, but instead focus on this simplified version, is because this is what Google practices in the AdWords system. It is simpler than this one. And in several lectures time, we'll look at a case where each user will input a truly different entries in the vector of preferences. and that will give us a lot more information about the scale of the preferences. In fact, too much information for us to consolidate those input vectors into a common output. We'll later come to this in voting systems discussion. The second question is, we had a bipartite graph, right? 3 white dots representing 3 bidders, 3 black dots representing 3 ad spaces. If you arrange them by R and C respectively in descending order, then GSP's matching is a simple straight line. In general, we have other kinds of bipartite graphs. What kind of graphs are bipartite? It means that all the nodes basically can be grouped into left and right. They don't have to have the same size. It could be 3 on the left, 5 on the right. As long as all the links connecting the nodes are across the left and right, but not within left or within right, we call this a bipartite graph. And this is a very useful visualization and analytic tool in many graph theoretic solutions. Okay. Auction is being a particular special case of bipartite graphs usage. We're going to later see more graphs, more bipartite graphs, and more matching methodology in bipartite graphs. So that's a quick detour. Now let's go back to that example. Which example? This example. Okay, we got 3 bidders with 10, 5, 1 being the R's, and 3 ad spaces with 5, 3, 1 as the click-through rates. So before we forget, let's write those down. Okay, 10, 5, 1, and 5, 3, 1. Okay. So now let's finish the discussion of this example. What kind of bidding would they provide? Let's assume they do truthful bidding. The keyword is assume. We'll later come back to why this is not in general true. But assuming that they do truthful bidding, then their bids are exactly 10, 5, 1 respectively out of 3 buyers. Okay. So in that case, we know exactly how much they'll bid. They'll bid $50 and $30 and $10 for the 3 ad spaces by the first user. The second user will bid 5 times 5, $25, $15 and $5 for the 3 ad spaces. The third one will bid 5, 3, 1 for the 3 ad spaces. Those are the bids. Okay, 50, 30, 10, 25, 15, 5, and 5, 3, 1. And the allocation is simple. Okay, first one get this one, second get this one, third one get this one. What about the charging? Okay, so the charging basically is that the first one will be charged by this. That's 25 clicks, dollars per click. The second one will be charged by the bidder, the bid from the third bidder on the second space. So it'll be charged 3. The last one would be charged the very small minimum, which is 0.5 in this case. Okay. These are in dollar amounts per click. So now we can take a look at the revenue. So Google collects the following revenue, which is 25 from the first bidder, 3 from the second, and 0.5 from the third, which is $28.5. And then the payoff to the buyers. There are 3 buyers, so we have to make 3 calculations. Remember, payoff U equals valuation V minus price P. So for the first one, you got the highest spot. So your valuation, which is 10, subtract the price you pay, which is 5 per click, equals 5 per click. Or equivalently, $5 per click times 5 clicks per hour on average is $25 per hour. And the second bidder's payoff is $5 minus 1. That's your valuation, and that's the price you pay. So what you get is $4, that's per click, which translates into $4 times 3 clicks per hour, that is $12 per hour. Finally, the third one, your valuation for the third ad space that you received is 1, and the price you pay is the minimum. So the payoff is $0.50 per click, which translates into $0.50 per click times 1 click per hour, which is $0.50 per hour. So the total payoff is $25 per hour for the first bidder, plus 12 for the second bidder, plus half for the third bidder, which is 37.5, and this is in per hour, just like here, per hour, because it reflects both the payoff per click and the expected number of clicks per hour. So this is how much Google is receiving in the revenue, and this is how much net happiness payoff is received by the three bidders altogether. So you may think GSP sounds pretty good. It's pretty simple to explain, the allocation and the charging, and as long as we can assume they do truthful bidding, it seems to be a pretty efficient allocation system, except we cannot assume that people will do truthful bidding. Okay, so here's a very simple example. We can write it in the margin of the slide. Let's say there are just 2 ad spaces. Okay, top one get 400 clicks per hour, next one get 300 clicks per hour. Okay, both are pretty powerful, but the first one's slightly better. And there are 3 bidders, 1, 2, and 3. Their valuation, which is the number of dollars per click expected, is $12, $8, and $4 respectively. Now, let's say, what should the first bidder do? You may think, well, maybe she should bid the truthful bidding. So she should bid 12, or equivalent 12 times 400 for the first spot, 12 times 300 for the second spot. But actually, if that's what she does, okay, she's going to win the first spot, and the valuation in that case, or the payoff, I'm sorry, in that case, is the valuation 12 minus the price you pay, which is by GSP 8, okay, dollars per click times 400 clicks per hour, and that would be $1,600 per hour. However, she can do better. She can actually, instead of bidding the 2-1, she can say, I'm going to bid, say, $7. You say, but then you won't get the top spot in the ad space. That's fine. Winning the top spot is not my goal. My goal is to maximize my payoff. And indeed, if I do this, then I will get the second spot, right? Because the second bidder, assuming truthful bidding, will get the top spot. I didn't do truthful bidding, I got the second spot. But look at what happens to my payoff function, U. Right? I get my net utility or payoff function be the difference of between my valuation, which is 12, and the price I have to pay. Well, since I got the second spot, I should pay the third highest bid. Again, assuming the third buyer bids truthfully, that would be 4. But of course, for each click, for this spot I don't get 400, I only get 300 clicks per hour. Times 12 minus 4, that's $8 per click. That translates into $2,400 per hour. Now this is a higher payoff than the truthful bidding one. Of course, this assumes that the second and third bidder bids truthfully. Only the first one chooses not to. But nonetheless, it is a simple but effective counterexample to show that GSP does not induce truthful bidding. One of the most desirable properties of second price is not carried from single to multiple items in GSP.